Here we go. And I've got very short notes. All right, so yesterday and the day before, we did permutations, okay? Yesterday, even though it was perfect yesterday because it was a chapel schedule and we could break it up a little bit, that we just kind of played with the calculator. You learned how to use the calculator for this. You learned how to quickly figure all this stuff out and everything, so it was very beneficial. There's other things that your calculators can do, and if we finish today early, then y'all can take those calculators out and we can play around with it a little bit more. I have a feeling you will finish rather early. Today, though, you learn about permutations and what they are. Today, you're going to learn about combinations. They are very similar and easy to get confused. Okay, very easy to get confused. Even the formula is very similar, but they're different. So today you're going to learn about combinations and the difference between the two. However, you still today cannot use that graphing calculator, kind of like we did permutations, to solve the problems. But you can use the little blue one, that does the solar thing. I'll let you use that, okay? Because, you got to do a lot of multiplying, just like with permutations. After you have done this assignment and shown all your work and turned it in, you may then get out the graphing calculator and play around with it, okay? Because it's pretty cool. And then if you have time, I can teach you other things too. Combinations is the selection of a number of items, that's an M, from a number of distinct items without, that means without regard for its order. So it's the selection of a number of items from a number of distinct items without regard for its order. And the big part is really without regard for its order. Okay, now look, we talked about, this is old notes. We talked about permutations. Look, Joseph, arrangement of a group of objects in a particular order. Order matters. So permutations, particular order, order matters. So it's an arrangement of items in a particular order, order matters. Combination, without regard for its order. So I'm going to put here in a different color, permutation, particular order. Order matters. Combinations, order doesn't matter. So you're basically looking for the same thing, kind of like with probability and everything, fundamental order of counting or whatever, the principal counting, I don't know. But anyway, you're looking for the possibilities or all the arrangement of blah, 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 blah items. Permutations in a particular order, combinations, order doesn't matter. Now, when we start reviewing for the actual test, you're going to be like, when is it a permutation? When is it a combination? When is it that fundamental order or principle of counting? Because they all are so similar. Guys, this is pre-algebra. I'm going to make it clear. I'm going to make it very clear. I'll even tell you if it's a problem that wants you to do a permutation, I'll put a P next to it. If it's a problem that wants you to do combinations, I'll put a C next to it. If there's no P or C, then that's the other thing. Okay? So I'm going to make it very clear, and you'll see that also in your homework. Okay, so an example would be if you have 7 books and choose 3 to take on a trip. We're not going to solve it just yet. You have 7 books. You're sitting there looking at 7 books, and you choose 3 to take on a trip. Does it matter if you choose one of the books first, or one of the books second, or third? No, you're just choosing 3 random books. Order doesn't matter. Now, if you have like 7 books and you're looking for a first place winner and a second place winner and a third place winner, order matters. You see what I'm saying? So this is an example of a combination because order doesn't matter. So let me show you, I don't know why, this is kind of reversal. The formula, I'm going to do 3 stars. Okay, so, and you'll understand this. This time, and you see it on your calculator, it's a big C with an N and an R. Just like yeah, that's right. When we were doing the calculator, you saw that one too. So they have a big C because that tells you it's combination. The other one has a P, that's permutations. Here's the difference. And this is, you have to have these memorized. The formula is N factorial, just like permutation, over R factorial times N minus R factorial. So Joseph, what is the difference in the formula from permutation and combination? What do you see that's different? Huh? That's right. This right here is the difference between permutation and combinations. That one thing you're multiplying by R factorial is the difference. Okay? All right, so let's go back to this example. Natalia, you're going to need to sit up so you pay attention. If you have 7 books and choose 3 to take on a trip. So, which is in, Joseph?
7.
That's right. And 3 books. So your total that you're choosing from is always going to be your first. And then whatever the specific number is, your R. And remember what I told y'all. Go ahead and put the N and the R underneath so it'll help. So now we have N factorial, so we have 7 factorial over R factorial, so 3 factorial times N minus R, 7 minus 3 factorial. Let y'all write that down. Any questions so far? Just like the last thing, but you're just adding that in there. Okay, so Joseph, what is 7 minus 3?
4.
Okay, so now I have 7 factorial over 3 factorial times 4 factorial. Do we all understand that? All right, now here's where it gets crazy. Natalia, you need to sit up because last time you were like this, you missed a lot of stuff and had me repeating it. I'm not repeating today, so sit up and you're going to be paying attention. So 7 factorials on top. Joseph, how do I write that?
7 factorial
Yeah?
over 3 factorial times 4 factorial.
Okay, but we got that. How do I write 7 factorial?
Oh, 7 times 6 times 5 times 4 times 3 times 2 and times
Very good. Over, now here you don't do 3 times 4 gives you 12 factorial. We're not doing that. You're going to do the 3 factorial and then the 4 factorial. So 3 factorial is 3 times 2 times 1. Now, what operation's taking place right here, Joseph? Multiplication, right? Times 4 factorial. 4 times 3 times 2 times 1. So does everyone see what I did? Do you understand the bottom part? Do you understand? Okay. So now we start doing our cancellation, but I need y'all to watch how I do this. I'm doing the, look right here. See how we can cancel the 4, 3, 2, 1 out? See how I did that? I'm going to take the most out first. Now, watch this. Can any of these numbers be divided by any of these numbers, Joseph?
Yes.
What?
3 and 6.
Very good. We could do 3 and 6, or we could even do 6 and 2, right? Right? Okay, so let's do 3 and 6. 3 goes into 3 how many times? Joseph?
1.
So I have 1 left over. 6 divided by 3 is?
2.
2. Makes sense, right? Okay, Joseph, is there anything else I can divide?
2 and 2.
Bingo! We can keep going. 2 and 2. 2 can be divided by 2. What is it?
1.
So I have 1. 2 divided by 2 is?
1.
1. So now I'm going to rewrite what I have left over. I really don't have to. What is, Joseph? What I have left over is 7, 1, and 5, right? And then down here I have 1, 1, and 1, correct?
Yes.
So, Joseph, what is 7 times 1 times 5 on top?
35.
And what is 1 times 1 times 1?
1.
35 over 1 is 35.
Whoa.
So all that work, and there we go. Any questions? None? All right. Let's see. I'm going to turn the page and let's do another example. Here we go. Okay, so I have 10 and 6, so N and R. So my formula again is N factorial over R factorial times N minus R factorial. So N factorial is going to be 10 factorial over 6 factorial times 10 minus 6 factorial. Ten minus 6 is, everyone?
4.
Okay, so I have 10 factorial over 6 factorial times 4 factorial. Okay, and we do just like the other. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 6 factorial, 6 times 5 times 4 times 3 times 2 times 1 times 4 factorial, 4 times 3 times 2 times 1. Now in this case, we want to take out as much as we can first, right? We want to eliminate. So this time, look at this. This 6 factorial is a lot bigger than the one we did over here. Like this was 3 factorial and 4 factorial. Taking that out is, you want to take out the most numbers at once, right? So right here, the 6, 5, 4, 3, 2, 1 would be the easiest to take out first. So we're going to eliminate that. Now I'm left with 10, 9, 8, 7, and 4, 3, 2, 1. So we start looking. What are some things that we can take out, Joseph?
3 and 9.
Okay, 3 and 9. So 3 can go into 3 one time. 3 can go into 9 3 times. Natalia, can you say something else?
4 and 8.
Yep, 4 and 8. 4 can go into 4 one time, and it can go into 8 2 times.
I see another one.
Okay,
2 and 10.
2 and 10. 2 goes into 2 one time. 2 goes into 10 5 times. That's it, because we have just a bunch of ones down here. Now, it won't always be a bunch of ones, but still, it's kind of nice. So, we're left with 5, 3, 2, and 7. Don't forget about your 7. So, to help on time, 5 times 3 times 2 times 7. Does anyone know off the top of their head?
210.
Girls, I can't do, my husband can do stuff like that. I can't do that. I gotta write it on paper. And then 1 times 1 times 1, blah, blah, is 1. So then my answer is 210. Human calculator over there. Okay. Any questions? Do we understand how to do this? Okay, I think y'all got it. So let's go ahead and turn to page 431. Wait a minute, hold on. Now I'm gonna make this nice and easy. It's Friday. So
Oh, I forgot it was Friday.
Wh- I'm not even doing examples. Not even doing examples. I'm gonna make this easier on y'all.
Wait,
What?
are you writing what we're going to do? Or?
Yeah.
Okay.
You're gonna do page 431. Ooh, I think I'm gonna have a little fun with this. All right, you're gonna do numbers 11 through 19 odd. No graphing calculator.
I'm just going to go with graphic.
Numbers 21 to 31 odd. You can, you don't have to, but you can use a graphing calculator. It's Friday.
I just put juicy.
Okay. Now, if you look in your book, 21 to 32, now listen carefully. It says label each exercise C for combination or P for permutation. Then find the number of different ways each can be accomplished. Now, what they're saying there is 21 to 32, it's going to be either combination or permutation. You have to know which is which by whether there's a specific order or not. However, it's Friday, so I'm going to tell you which is combination, which is permutation. 21 is combination. You better write this down. 23, combination. 25, permutation. 27, combination. 29, combination. And 31, permutation. So you need to write that down. You can even mark it in your book. So for these problems, I've already told you which is combination, which is permutation. All you need to do is do the work, find the answer. And you may use a calculator for that, graphing calculator. Any questions? So here, do it the old-fashioned way. But you can use the little blue calculators. Huh? Old-fashioned, well, with semi-no technology. And then here, you can totally use graphing calculator. This is going to be due Monday, You can borrow Tanner's. Quiz, Wednesday, and exam is the week after that. Any questions? All righty then, y'all may get started.